I needed a board for a project at home, one of those small microcontroller type boards found all over the internet nowadays. And I came across this. It's a Freenove starter kit that contains an ESP32 rover board. Let's have a look and see what it can do. The kit comes with an expressive ESP32 chip. It's a 38-pin chip. It has built-in Wi-Fi. This is the antenna over here. It came with the camera pre-installed, along with this great GPIO breakout board that makes things very easy to connect to a breadboard. 3.3 volts here and 5 volts there. I decided to make a mock-up of a robot that could wander my house using some of the components found in the kit. This is the ultrasonic distance sensor. The chip there is a serial to parallel shift register, an LED bar graph, a small LCD display to show some details of what's happening in real time. And this is a servo motor that I can change the angle depending on the distance in front of the ultrasonic sensor, all while being able to view the live stream provided by the camera. So let's start it up and see how it goes. The aim was to see if I had to place this kit on top of a roving robot motorized platform. As soon as some object is found in the view of the ultrasonic sensor, I would be able to change the angle of the servo motor here and display it on our display along with the distance from the object. The LED bar is just there to see if I can have a visual representation of the distance changing in real time. Here we'll place an object in front and you'll notice that the servo motor changes its angle to 20 degrees. And the distance is now measuring 17 centimeters. And this will change along with whichever object comes into its path. Basically, this was a test in object avoidance. As the object gets closer, the angle will change and the robot will drive around the object in its way and then slowly straighten out again to 0 degrees. And if it encounters anything else, it will slowly move the servo motor so that the wheel could turn and avoid any objects in its way. Let's jump to the computer so that I can show you the real-time streaming server while all the components are in use. Here I am logged into the streaming server through my local network. Let's start the stream. What I'm going to do is place my hand in front of the camera so that you can see what the reaction time is. As you can see, there's not much of a delay. Let's do this while we're moving the object closer. So you can see there is a small delay there. I doubt whether that will affect the robot running around. Let's take, for example, an object getting nearer. I'll bring my hand closer to the camera at the same time so that you can see the angle and the distance changing along with the angle of the servo motor. So all in all, it seems to work quite well. This chip has a few other functions that I'm not using at the moment. Bluetooth is enabled, just not in use at the moment. But all in all, it seems to be a great project board.